So we'll try an example of the second derivative test. The question is, determine the points of inflection and discuss the concavity of this function. Okay, so in order to find inflection points and concavity, it's the second derivative test. So I need to do the derivative, and then I have to do the derivative of that to get the second derivative, and then I'll do my testing. So I'm going to start with the first derivative. And since it is a quotient, I'll use the quotient rule. Bottom times derivative at the top minus top times derivative of the bottom all over the bottom squared. I'm going to simplify before I move on, and I end up with 2x cubed minus 8x, and then I'll distribute that 2x and the negative 2x cubed minus 2x all over x squared minus 4 squared. It looks like my cubed terms cancel out, and my first derivative is negative 10x over x squared minus 4 squared. If I were doing increasing, decreasing, and extrema, I'd be able to test now. But I have to do concavity and inflection points, so I need a second derivative. So now I have to do the derivative of that. Again, it's a quotient. I'm going to use the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom. I'm running out of room. And that's a chain rule. I brought the 2 down, made it a 1, and then I did the derivative of the inside. All over the bottom squared, which would make it to the 4th power. All right, so second derivative looks like it'll be, I'm going to have to FOIL that and distribute my negative 10, unless I can do something a little bit different. I'm actually going to rewrite this so it looks better, and I'm going to talk about a simpler option. So I'm going to put that negative 10 in front. Minus a negative, so that'd be plus 10x times 2 is 20x times 2x would be 40x squared. Okay. You do have the option here to FOIL, distribute the negative 10, distribute the 40x squared, and then combine like terms. That is totally fine. I'm going to do something that I think is a little bit easier. I see that if you look at this as a term and this as a term, that the greatest common factor here would be 10. And then they have this in common. They each have an x squared minus 4. This one has 2 of them. This one has 1 of them. So I'm going to factor out on top the greatest common factor, which is 10. Actually, I'm going to do a negative 10. Negative 10, and then I'm going to factor out 1 of the x squared minus 4s. When you factor something out, whatever's left goes here. So I took out a negative 10, so that's gone. I took out 1 of these terms, so I have 1 left, x squared minus 4. I took out a negative 10, so that would be minus 4x squared. And then I took that out, so that's gone. So this is the top factored. We talked about how to do this when I taught you the chain rule or quotient rule, I can't remember. But it's another way to solve it that, I don't know, I think it's a little bit easier and less terms than if you were to FOIL and distribute and combine like terms. So I like it a little bit better. And I get to reduce because I have an x squared minus 4 here, and I've got 4 of them down here. So I can take that out and make that a 3. So this is my second derivative. I'm going to rewrite it so it looks better. So negative 10. In the parentheses, it looks like I've got x squared minus 4x squared. It looks like I've got a negative 3x squared minus 4. And then x squared minus 4 cubed. This is my second derivative. And this is what I'm going to be testing with. So the testing is first, find your second derivative and then find critical numbers. And critical numbers are when the function is equal to, the second derivative is equal to 0 or undefined. So I'm going to take the top, set it equal to 0. I'm going to take the bottom, set it equal to 0, and that would be where it equals 0, and that would be where it's undefined. Now if I divide both sides by -10, I have that. I'm going to add 4 to both sides, and divide by -3, and then square root. So all that work actually led me to an imaginary number. So there are no critical numbers that came from setting the top equal to 0. I'm over here. I'm going to cube root both sides to get rid of that cube. Cube root of 0 is 0. I'll add 4 to both sides and square root. I end up with 2 and -2. Those are my critical numbers. I'm going to pause the video and I'll finish my testing on the next video.